Hi, everyone. Welcome to another session on cybersecurity at Aggregate Intellect. At Aggregate Intellect, we focus on theory and applications of AI and machine learning and other emerging technologies. Do follow our LinkedIn page, our YouTube channel, and our website, ai.science. Today, I'm glad to be hosting Kristy Edwards, who is an expert in cybersecurity and has worked in various areas in cybersecurity, including mobile security, data privacy, and security and risk management with companies such as Oracle, Workday, Lookout, and presently at Zen Data Privacy. In her talk, Kristy will be talking about applications of AI and machine learning to mobile malware detection. With mobile phones playing an integral part in our lives, the ability to be able to detect attacks against mobile devices is key. I'd pass it over to Kristy now, who would share with us her thoughts on applications of AI and machine learning for mobile security and mobile malware detection. Over to you, Kristy.
Great. Thank you, Abdul. I'm so pleased to be here. When you first started and asked me to speak at Aggregate Intellect Toronto, I thought of how convenient it would be to host this from home. But I also thought about how great it would be to be in Toronto and do this live and meet everyone in person and have the conversations, maybe go have a coffee afterwards. So one day we'll get back to that post-pandemic. So I've got my coffee made at home and I'm ready to dive in. The other thing that's new since we started talking, and you mentioned a little in the intro, is that I'm now the proud co-founder of Zen Data Privacy, which is a data privacy technology startup that's helping customers to shift left and bridge the gap between privacy teams and dev teams. So we can maybe chat a little bit more about that then in the afterwards in the Q&A and explore some of the related ML topics. But now I'm ready to talk to you about machine learning and the role it plays in mobile cybersecurity, both its benefits and its challenges. So I'll start with a quick overview from industry's point of view, and then critically give you some background on the threat landscape and why it's so important to understand the threat actors and their TTP, which is tactics, techniques, and procedures, which is a term that we use to describe the patterns and activities or methods that are associated with a specific threat, a threat actor, or a group. So it's really critical to apply an understanding of the threat actors for us to really understand who's attacking whom and what motivates them. Why? Of course, so we can stop them. But the part I think that you've been waiting for is to what extent we can and cannot rely on ML in fighting cyber threats. And then I'll bring it all together with some learnings and recommendations and open it up for Q&A. So to start, companies are using AI and ML to address cybersecurity challenges across the gamut. We know Wall Street and venture companies are not only interested in applying AI and ML to this space, but they're also putting dollars behind it. There's an obvious fit here. Successful ML implementations require good quality data and large amounts of it. And we've got no shortage of data on these platforms. And we're talking about, terabytes of data, and that number is constantly growing. And there's a real need for fast, automated, scalable solutions that fend off cyber threats. So that's why AI and ML fit in so well here. So let's quickly look at some market sizing. In this recent report, I like this recent one from Forbes because it's like a compilation of several market forecasts and estimates for ML. And they reported a projection that by 2024, the global market for ML will be worth over $30 billion US. And that's up from 7.3 billion last year in 2020. So that's pretty significant growth from a pretty decent sized $7 billion starting point last year. Interestingly, Forbes also reported that 71% of organizations that they talked to report that they're spending more on ML for cybersecurity now than they were 2 years ago. And also that 84% of those industry folks said that they believe that their adversaries, the cyber criminals, are also using AI and ML in their attacks against us. And I completely agree with that. They're exactly right. So really to look at ML models and which models apply best to cybersecurity. I mean, cybersecurity is so broad, but let's take a look at a couple of use cases. So to start, with unsupervised ML scenarios, as you know, unsupervised models allow us to draw inferences and find patterns without referring or using labeled outcomes. So clustering can be really good to apply to fraud detection, for example, because it allows for anomaly detection when you're finding outliers. Similarly, clustering is good for network security applications, intrusion detection, and so on. I think we find even more applications for supervised ML in cybersecurity, where we're classifying with labeled outcomes. So simple kind of binary example, and there's a good Google blog on this actually, is whether email is spam or whether it's legit. So Google uses supervised ML to block, they say in this blog that you'll see at the bottom of your screen, as much as 50 to 70% of all emails that Gmail receives every day, which is spam. So really huge numbers there, right? Phishing is another great use case. In particular, predictive URL classifier models. These models are trained on things like email headers, some contents like some of the contents of the email body text, things like punctuation patterns and those types of attributes. So this can really help us to identify patterns in senders' emails when you're classing emails as phishing or spam. So this is another place you can really scale your phishing protection by leveraging ML. And then another place that unsupervised models can be really impactful is predicting whether a mobile app is clean or malicious. And I'm going to tell you a little bit more about that. You can read about some of these applications here in the URLs at the bottom of your screen. So let's spend a few minutes thinking about the attacks and the attackers. Right? This is where our real world experience really comes into play and is so critical. So who's attacking who on their phones and how and why and what do we see in terms of sophistication? Well, let's start out here with smartphones. You know, they're so integrated into our lives, both for personal and professional reasons. So if you think about it, we use our phones to do everything from communicating over text and email, sending encrypted messages, to consuming news and tweets, far too many tweets in many people's cases, but also accessing business data from our corporate networks or from the cloud, and, you know, oh yeah, to make phone calls. So with this, as smartphones become more integral into our daily lives, they've also become more valuable targets for the attackers, or because they're so integral in our lives, they're so valuable for attackers, right? So, and the data really supports this. We see more and more attackers adding mobile exploits to their TTP, their tactics, techniques, and procedures. They're not replacing traditional attacks on networks and laptops and supply chains like we saw in SolarWinds, but they're certainly adding mobile capabilities. And if you go look on Lookout's website, for example, you'll find out a lot more information about this. But let's talk about the attack surface a bit. So you have threats, you have vulnerabilities, so things like unpatched OS versions, unpatched like old versions of apps that have now well-known vulnerabilities that are likely to get attacked. And you have behavior and configuration issues. And we're talking, by the way, about both iOS and Android, mainly iOS and Android here. What I'll be concentrating on are the threats and vulnerabilities. So who are the attackers? You know, it really runs the gamut. From individual fraudsters at one end of the spectrum, they're out to make a buck, for example. They're making money using adware, where the attacker makes money from every ad impression they provide to advertisers. So as you're getting those annoying little pop-ups, they're getting like a cent or some fraction of a cent every time they serve up one of those ads. And then you kind of get over to more sophisticated groups or individuals who buy malware and phishing kits on the dark web and then deploy them in their own phishing campaigns or their own malware campaigns. Sometimes these are ransomware attacks where a user's data gets encrypted and their only choice is to pay the ransom, usually via some kind of cryptocurrency, to recover the data. And then there's where it gets scariest and most personal and really most dangerous, which is when you have well-funded governments or state-sponsored actors who are spying on individuals via their phones. This is where I personally have witnessed how valuable the data can be and the communications can be that we rely on our phones for, and how they can be attacked most viciously. Right. So this is why we're really concerned about it and spending the time and the money trying to catch and thwart and stop these attackers. So what type of information are they after? This is a graphic from Lookout's report from a couple years ago on dark clerical, which I had a minor role in. It shows the data that this nation-state actor exfiltrated from their victims' Android devices. You can read the whole report. It's super interesting. You'll see the URL there. But they exfiltrated almost 500,000 text messages during this campaign from multiple victims' phones. They also captured, you can see their call records, browsing history, contact databases. So if you think about this type of spying, it's so intrusive and damaging, and it can be so dangerous if a well-funded nation state has gotten your contacts and your call records and your text messages. Imagine how dangerous it could be for you, for your friends and your family. Further, industry experts like Microsoft have found that cyber threat actors are getting more sophisticated. Microsoft published their digital defense report a few months ago, detailing how cyber threats are getting increasingly sophisticated. And I've seen this myself. For example, just to talk about some of the evasion techniques that we're seeing on mobile platforms. This isn't a comprehensive list, but it's a good sampling to see different ways that threat actors hide their tactics with fake or repackaged versions of otherwise legitimate apps. So it has all the functionality that app, the real Facebook or real messaging app has, or real banking app has, but wrapped with additional capabilities that are malicious. Another is by using second stage attacks, where they might get their app into Google Play, for example, because it's a clean app, it doesn't have malware in it, but then deliver the malware in a secondary app or payload once you've already installed the clean version on your phone. Another evasion technique is by hiding the infrastructure in AWS or Azure or other cloud infrastructure for their C2, their command and control infrastructure, which provides the instructions to the device and captures the stolen records or data. So this makes it really much harder for the good guys, that's us, to find or take down the C2s versus if the attacker is running their own internet-facing infrastructure. So how does industry fight back against these ever-changing and increasing threats? Well, we too have a very sophisticated arsenal of our own tools, tactics, and techniques to thwart and catch attackers. We're using the cloud to scale. We're leveraging ML to be both effective and efficient, and at scale to protect corporate information, networks, sensitive data, and PII, and a lot of those communications that I just mentioned. So let's dive in and look a little bit more at how we leverage ML. So a typical, very kind of vanilla ML pipeline is outlined here. One good thing about this explosion of iOS and Android apps out there is you get the really large numbers that you need for ML to be successful. And I don't just mean the apps, but you'll see the analysis of the apps in the next couple minutes here. So we're talking, in my experience, about 80, 90, almost 100,000 apps that are processed every single day. So this is plenty of app analysis results to use as your training data set. So this is where I've learned that a supervised ML model fits best when you're classifying clean apps versus malicious ones. So this is where I've spent a bunch of time applying ML to the cybersecurity problem. So it turns out to be a pretty good use case because you have tens of thousands of apps and app versions that are analyzed every single day. So you have the numbers that you need. And you also have threat intelligence from millions, tens of millions of clean and malicious apps that you can use for your training set. But this is, maybe a little academic or basic or theoretical. So how does ML fit into the bigger picture of mobile threat detection? Well, you can't just run an app, like a compiled app, across an ML pipeline, right? First, you need to do some feature extraction where you need to know what attributes you should be sending to your ML pipeline. So this is really critical, and it takes research and knowledge and expertise from people who have been doing this for years, right? There's special app analysis tools. There are people who specialize in malware reverse engineering. There are, super, super smart security people and architects who understand it and who design these systems. So I won't get into, tons and tons of detail here, but suffice it to say that you have data scientists who work really closely with the people who are really knowledgeable around app analysis and around how these threat actors work and how they avoid detection to make your ML model be as useful as possible to achieve the business goals. So if you look at kind of one typical stack. This is, I pulled this off of, it came from Broadcom, but it's actually Symantec's endpoint security stack. And this is not necessarily just mobile. But I wanted to show you a system that I think is somewhat typical, right? You can see all the different pieces of analysis that go in from like the 50,000 foot view to give you perspective on the entire platform. And you can see how ML is but one piece of it. So I'll show you a little bit more about how ML comes into play and how people like some of these guys here and me when I was at Lookout were using ML on a daily basis to help us identify and classify apps as malicious that are masquerading as legitimate ones. So let's look at applying ML at scale. Here you see there are many parts of the app analysis journey, and this is also just like a super high-level overview. the first thing to note is that ML that has this little blue dot is really just one stop. So all the components are critical, and they all play an important role in finding malicious apps among the tens of thousands of good ones that get analyzed daily. And I mentioned there, like in Lookout's case, there are like 90, almost 100,000 apps that go through all this analysis every day. And approximately about 5,000 are marked as malicious every day, just to get an idea of the ratio. So the apps necessarily first have to go through static analysis, where we learn about the code, embedded libraries, SDKs. It's important to pull the permissions and capabilities. Those are super helpful for doing prediction, feeding that to the ML engine, and also to detect vulnerabilities. And by the way, this is all like publicly available information that's available on the Lookout website. Let's see. So they go through static analysis, and that's where this feature extraction is really critical for ML. I'll come right back to after I talk about dynamic analysis. So this is where in the cloud you actually install and run the app in a sandboxed environment to see how the app behaves once it's installed. So here you can watch what endpoints it talks to. You can sometimes identify that an app looks clean, is making calls or taking instructions from a known malicious domain or a C2 command and control infrastructure that you know is controlled by bad guys. So once you've got all this type of analysis data and then multiply that times the hundreds of thousands of apps that it sees every day, it's a good time to bring in your ML engines. Also important to note what you're seeing over on the right side here. The vast majority of threat detection is automated, but at Lookout, for example, there's a whole team of security researchers that spend their day spelunking through threat intelligence data stores, reverse engineering apps, and manually searching, in some cases, for threats with embedded malicious code. That might otherwise evade detection, right? So there's a lot of automation in there, but some of that automation is really just to prioritize a queue for the researchers to go take a look further into manually. But now we come back to like the real world issues and where does ML sometimes fall short or ML in an academic setting? What are some of the things from like real world implementations that we need to think about? So here's a couple of real world issues that I've lived. I think these are especially important for data scientists who come from academia to consider because things in enterprises are almost always like super messy. So if we rely primarily on ML prediction to judge just malicious versus clean, make that binary decision, the problem is there are apps that have behaviors like load at boot time and a high number of capabilities and permissions. These are great indicators or predictors of malware. But think about this example. You can have a malicious app that tries to load at boot time and also take actions like accessing your text messages or escalating privilege. Sounds like malware. But now think of a security app that needs to load as soon as you boot the device in order to do its job, and it has to have enough privilege to do the security monitoring that you actually want it to be doing. So an ML model might give both of these high ML scores, like maybe as high as like, 0.7, 0.8, depends, right? So now think through the real world implications of, say, a leading mobile security app that detects a competitor's security app and alerts customers that you have malware on your device. So think of the brand damage that it would cause if, with a false positive, right? If you made the mistake that app and that security app is actually detected as malware. Another way to think about FPs is if you think of like your email provider, like Gmail that I mentioned earlier, and how much spam that they're fighting off every day. Even with all the data, all the training, all the feedback loops that I mentioned earlier, and all those training sets, you still receive occasional spammy emails, right? And you're kind of like, how did they not catch this one? But the same principle applies here. An FP means that you might not see a perfectly good email that your brother sent you, and that's not an outcome that you want. And a false negative means that you'll see the spam, right? So they too have to err on the side of caution. So these are a couple of practical issues that we have to grapple with in the cybersecurity world when we apply ML to real world problems. So something we found useful is that you really need to implement guardrails when you're relying on high ML scores to make security decisions like predicting malware. So you need to put guardrails in place, for example, if you have a high risk score from your ML engine, but you also find that the app, say, has lots of installs in a particular country or region. You might want to flag that for a researcher to review it manually, but this is a place that you probably don't want to automate, right, just on the basis of a high ML score, even if it's really quite high. And I will tell you that there were times that as the product manager, I was so excited after we retrained our ML engine and we really had things up and running. I really wanted to go with some of these new features, and I had a lot of very smart and cautious people around me who really drilled in the importance of building in the guardrails, right? So we don't get those FPs because they can just be so incredibly damaging. Couple of other gotchas before I get to my very last section here. So I've been lucky to work with a couple of different academic researchers in the ML space. A couple of gotchas that I've observed. One is that they may have deep expertise in ML, but not in the evasion techniques of mobile threat actors and some of the other specific issues that we security folks understand really deeply, which I've talked about here, but I've barely really scratched the surface in the short time that we've had here so far today. Second, I've seen researchers using old and out-of-date data sets as training data, and this doesn't do anyone any good. So I'd advise looking for partners in the enterprise space who can share anonymized data or data that doesn't include PII. There are, literally petabytes of data that's processed, right? It's mind-blowing. So, and there are often folks across industry that are happy to work with data scientists and people in academia and very willing to exchange knowledge. So in closing, what can we learn? So one is that we cannot rely solely on ML. We need knowledgeable data scientists. We need the proper tools and large and quality data sets, with quality data. We need to automate and scale. That's the name of the game. And we need what we need most are cross-functional teams of skilled data scientists and security researchers and other security experts. And we need to provide them with the tools for threat hunting and analysis, tools to automate, but also to allow researchers to do their own specialized research, which is really what's required for success here. And when you see talks at Black Hat or DEF CON or headlines around discovery of another mobile APT or another threat actor that's stealing information, exfiltrating personal data off of people's personal devices or business devices, you really see, that's where you really see the compilation of all these things that we're talking about here, right? You can't rely on the technology alone. So in closing, it's really a Venn diagram that's needed where we all work together, we all learn from one another. We need the tools and the budget to support our efforts. ML is absolutely a building block. It's one of the tools we need and we really rely on in mobile security. So for example, I can recall receiving an automated alert from originating from our ML classifier on a high apps with high risk scores and high ML scores, and that tipped us off to a whole bunch of banking Trojans. But more often, our researchers would rely on querying or splunking through our threat intel databases and other threat intel sources to discover novel threats and find the more serious attackers, say like Chinese nation state actors who produce surveillanceware that victimizes Uyghur populations. So there's a lot of like that run-of-the-mill, adware, even banking Trojans and things that can get picked up through this automation, and I include ML as part of that automation. But then there are other places where, like in this nation state scenario, I'm thinking of where an ML classifier will often play a smaller role, and there's this, specialized knowledge that super smart security researchers really bring to the table. So then at the same time, we need super smart data scientists to retrain our models, measure accuracy, keep an eye on loss of accuracy, and keep an eye out for things like to see if there's bias in your data set, and so much more. So that's why we all have to work together to achieve the business results that we want. To keep catching and preventing the bad guys from attacking us. So with that, I want to thank you so much for your time and attention. And Abdul, if you're ready, I'm ready for some Q&A.
For sure. Thanks a lot, Kristy. That was a super interesting talk. And I'd encourage the audience now to ask their questions away as well. Kristy is an expert in cybersecurity. She's worked on a number of domains, not just mobile security. So she's worked on data privacy and like a whole lot of other domains within cybersecurity. So like I would encourage to just ask your questions away, like any questions you'd have on cybersecurity. So yeah, perhaps I can start with a few of my own questions, Kristy.
Great.
So I think in one of your slides, you were talking about reputational scoring and how you basically use reputational models for scoring applications. So if you can go a bit more into details as to how those reputational models are built.
Yeah, sure, absolutely. So reputational models are another way that security vendors can leverage, the terabytes of analysis results and app metadata that they have, in this case, to measure the risk associated with an app developer. So one way to think of it is if we suspect that like a game app is malicious, we can look at information in the app developer certificate, which they need to use to sign the app, and get other information about, for example, like how often we've seen that same developer create benign games that are used and installed, in a particular region or used widely around the world. So this gives us really good insight into who the developer is and whether they're known to us as a malware author or if they're reputable. So yes, reputation scoring is yet another trick that we have up our sleeves to understand potential adversaries and to leverage information that we have to separate the adversaries from the benign apps and from the benign app developers.
That's interesting. So it's interesting. You mentioned a couple of features, basically. I mean, like you mentioned a few features in here, right? That you essentially use for your reputational models. And you mentioned like multiple categories of people, basically, like working together on mobile security. So who comes up with those features? I mean, would it be the domain experts, basically, like that sort of say that, okay, these are the features that we should be leveraging for reputational models, or is it the data scientists, basically, like that use data science and statistics and like other mathematics and statistical techniques, essentially, to come up with some of these features that should be looked into? How does one come up with these features, basically, for reputational models?
Yeah, it's a great question. So, as product manager, I like to say that the product manager has the ultimate say on what those new features are, and in really owning the roadmap and building out the order in which, the timing in which, the details around what the feature is going to look like. But those inputs come absolutely from data scientists, as well as from the security researchers, the architects that know this area so well, from spending time with customers, enterprise customers, consumers, and the large carriers around the world, who are serving those in the B2C world. So the inputs come from everyone, but at the end of the day, it's really the product team, who owns the roadmap and really decides like how and when you're going to maybe build in a new reputational scoring model, or maybe end of life something and replace it with something brand new.
Interesting. And you also mentioned like multiple categories of people over here again, right? I mean, like the data scientists and the security researchers, essentially. Like the data scientists perhaps wouldn't be too aware of the domain. So I mean, like to do to come up with effective algorithms and all, like do you think that they have to perhaps like at some point understand the domain really well and basically like deep dive into cybersecurity, or how does that work out for them?
Yeah, I mean, I'd love to get your perspective on this too, Abdul, but I think the best data scientists in cybersecurity are the ones who, of course, they come in as experts in data science and in AI and ML, and this is such a sought after area of expertise, but who also really spend the time with the security team. And I know, and I'm probably guilty of doing this in my talk, I try so hard not to use too much jargon and acronyms. I probably just used a million of them without realizing it. But yeah, I think you need your data scientists to really come up to speed. They're not going to be the deep experts in security, but by the same token, the security people aren't going to be the deep experts in AI, right? So, but they need to get as deep as they can, and just spend time literally like sitting in the desk like next to us or across from us, which I was lucky enough to have when I was lucky enough to go into an office back when I was a lookout. Would you agree, or what do you think?
No, I mean, I think the same, right? So ours, like, I mean, at TELUS, my team is working on intrusion and threat detection systems, and the way we are doing it essentially right now is by looking at like a whole bunch of network traffic and some of the host-based logs that we get, and by correlating them as well. And ours is a very small team, so I think like what I find is that we have to basically sort of look like we don't have an option, basically, like not to be security experts, right? So we basically we have to deep dive into security to understand the domain really well, so that we can essentially do effective data science and essentially build effective AI and machine learning to solve the problems at hand, right? Because I mean, we can, yeah, there's not an option basically of like we don't have an option of like not understanding the domain, right? Like to
Right.
yeah, to build like effective stuff, yeah, we need to basically be doing that. Yeah.
Yeah.
So there's a question in the audience. So It's from Ashok. He says that thanks for the amazing talk, Kristy. So the question goes like, from machine learning perspective, can you share light on any standard frameworks, libraries in mobile platform, or if possible, if you can share in industrial network? So I'm not sure if the question, do you understand the question, or do you want me to repeat that?
Let's see. So frameworks and specific libraries and so on that are being used on mobile platforms like for ML. If I understand the question, actually, Ashok, I wish I had a better answer for you off the top of my head. Maybe in the comments, actually, afterwards, we can get some of my colleagues who can probably think of like some of those libraries off the top of my head. I have to tell you, as a product manager, I'm not. Yeah, that's just something I can't. I don't know off the top of my head, but yeah.
Yeah, the question is sort of not clear to me as to what it's asking. So, I mean, I'm just not sure like what frameworks and libraries for what. Like, I mean, is it for doing mobile malware detection, or what's the like what's the question trying to ask? Like, I'm not entirely sure as well.
Yeah. Yeah.
Awesome. I think so. Okay, so he made a comment again. So he's saying like, in security of ML algorithms, we saw recent development of clever hands, etc., etc.
Okay.
I'm not. Yeah.
Yeah, I'd Google it.
Yeah.
Sorry, in
Yeah.
this case, Google's going to give you
Yeah.
a better result than I am.
Yeah. Yeah. I think his questions perhaps is more around like machine learning libraries. But yeah, anyways, I guess we can move on to the next question that I had. So this thing. So you talked on some of these areas. What So, I mean, can you comment, like you've worked basically on multiple, you worked on like multiple areas in AI and machine, like, sorry, you worked in multiple areas basically in cybersecurity, Kristy. Like you've worked in data privacy, you worked in like mobile security. Can you basically comment on, let's say, like how AI and machine, like how effective AI and machine learning would be like for these other areas in cybersecurity?
Yeah, I mean, there are so many tools, like we were saying, security is just such a broad topic. And there are so many tools that we use in the SOC, the Security Operations Center, that rely on AI and ML. There's one thing that I only touched on, which is phishing protection. On mobile platforms, phishing is like the most common attack vector. It's how intruders get onto your device. The Verizon DBIR annual report and their mobile security index, Verizon's MSI, have lots of data points on phishing. I know from reports like those and from personal experience that users are 3 times more likely to click on a phishing email or text or DM on a phone than on a desktop, because on the desktop you have a bigger screen, you can see the full URL, you can see if it looks fishy. So anyway, this is a place that we're seeing supervised models for classifying clean versus malicious URLs, and unsupervised models for like doing clustering around URLs and domains to find the outliers. So this is a place that AI and ML is really fundamental to many vendors who have phishing protection solutions, and phishing is such a huge issue for people right now. So maybe it's worth another talk from someone on that topic.
Yeah. So in some of these areas that you've mentioned, where would like AI and ML basically like fall short of its promises? So you mentioned SOC, you mentioned phishing. So other areas that you've worked in cybersecurity, where do you think that AI and ML applications would fall short of its promises?
Yeah, I mean, I think like I said, even in mobile cybersecurity and in malware classification, on its own, it would fall short, right? But we've kind of talked about all the supports around it that you need and how it fits in. But there are other tools we use in the SOC, the SIMs, the intrusion detection systems. Those are great examples of where some of these ML models are really valuable, but by the same token, they can fall short in that they're always going to be false negatives and they're always going to be false positives, right? So I already talked a little about like the business impact, the human impact that FPs can have. If you think you have spyware on your device because your security app told you that you do, but it turns out to be an FP, it's not really spyware, you're not going to be very happy with your security app. And the company producing that app isn't going to really probably stay in business too long. But by the same token, you can't have too many false negatives. Like think of false negatives in your SOC. In those tools, it means that you're missing APTs, you're missing threats that are lurking on your network. That's really bad, right? Look, like the entire industry missed SolarWinds for like 9 months. That's a bunch of false negative, right? So there's a place that we've all fallen short. That's months and months of false negatives across government implementations and industry customers. So I think there's a lot of innovation needed and a lot more development needed to improve the security tools really across the board.
So perhaps that's a good segue into my next question, and perhaps I'd be changing like some like gears on mobile security essentially. So like we're talking like we're talking about 5G basically, right? And we are essentially like talking of there being like exponential data and there essentially being tremendous increase in the number of applications basically. So and so what you're saying over here is that like it's hard to basically like go like fully automated, right? So in this whole 5G setting, when there would be like tremendous increase in the endpoint applications and exponential data, like how would like how effective would essentially be, like how effective would cybersecurity be like if we're not fully automated, right? Like somewhere if there's a human in the loop and the human basically has to sort of like look at look at the workflows or make some decision, even though we have like let's say like 90% automation through SOAR tools and whatnot, if there's still like human in the loop, like in this whole 5G setting where we like data is increasing exponentially, we have use cases like healthcare IoT, or autonomous or connected vehicles, which perhaps even need like faster response times. But we're not there with AI and machine learning yet, where we can be where we can automate the whole workflow of cybersecurity and intrusion and threat detection. Like how effective do you think would cybersecurity be in that cases, and would we be able to support these use cases like intrusion and threat detection basically in let's say like healthcare IoT devices or or autonomous and connected vehicles where you need faster response times and human lives are at stake, right? Would love.
Yeah. Yeah, that's a that's a great question. And you're right. Like I said, you have to automate, automate, automate. You need to scale. And I think you pointed to some really great areas where you can't have a human in the loop. So so take autonomous vehicles you mentioned. You can't have a human in there, as those second by second decisions are being made. So that's a vertical where there's a massive amount of data collection and safety requirements. So there's tons of applications for AI and ML there. I think you probably know more about 5G than I do and those implications. But, I've spent time in health IT, both at McKesson and in Oracle's health sciences business unit, or working with that business unit when I was at Oracle. And my observation is that health tech has a long way to go just to come up to current security best practices. So to me, healthcare IoT is like super scary. It really needs to be approached very carefully. You definitely need that Venn diagram, the systems, the knowledge, the data that I showed you, where you're bringing the experts together. But I'd make that applied knowledge circle, like the people, the experts part of it, I'd make that circle like even bigger. And have you bring in those healthcare tech experts, because it's just it's a kind of a scary place right now.
So do you think that AI and machine learning would be able to fully automate, like let's say like this whole process, at least like for intrusion and threat detection, like would it be able to fully automate this pipeline, or do you think that like at least like in the foreseeable future for the next 5-10 years, like would there still be humans in the loop over there?
I think it's a little bit of both. I mean, I think that a lot has been uh, uh, automated in the IDS space, and with the tools that we're using in our SOCs. But I also think in our security operations centers. But I also think that there are almost all. Well, you at least have to have the human monitoring the system, and you at least have to have alerts coming up, right? And you'll train the system, and you'll make it better and better with that human knowledge, so you can be little by little removing the human. So yeah, I think there's certainly applications in network security and in the SOC that you can have that kind of automation. But again, there's so often need for at least human oversight, even if they're not there, like involved in the workflow, at least for the human to be involved. Is that, I mean, you're spending a lot of time on intrusion detection systems and so on. Is that what you're finding, or do you think that there's, you're seeing a bunch of areas where you can remove the human?
No, I mean, like in the pipelines that we have built, like humans basically like still have to inspect like even the outcomes coming from AI and machine learning, just because we like it's not 100% certainty, right?
Yeah.
And to what you said earlier in your presentation, that there's always this brand name risk. So if we basically like say something which is not true, I mean that can damage the brand name as well, right? So there's definitely humans that are essentially still looking at the output that's coming out of these AI and machine learning pipelines, right? Is what my experience is as well.
Yeah.
But
Likewise.
I'm curious as to how that sort of would pan out when it comes to like, let's say like connected and autonomous vehicle use cases or healthcare IoT use cases. But I'm just starting to dive into these use cases, so I think I'll figure it out.
Yeah,
Let's see.
yeah. Well, and I mean, there's a lot of that is like greenfield. There's so much room for innovation there, and because of those huge data sets and that constant data collection, like especially when I think about the autonomous vehicle, and there's not the same, healthcare and privacy concerns. Uh, there are certainly still privacy concerns in the AV autonomous vehicle space, but not to the same extent as healthcare. So that might be, a really good area for deeper exploration.
Yeah. So now that you bring up privacy, and I think you're also working now, like you're also working as a product, like as a chief product officer, basically in Zen data privacy. Like, can you basically comment on the applications of AI and machine learning for privacy enhancing technologies? Like, what role can AI and machine learning play over there?
Yeah, I've been spending a lot of time thinking about this. So I'm right now deep in developing my new company's long-term product roadmap. And of course, as you know, when you're building a product, you have to, crawl, then walk, then run. And we're starting out with some more simple solutions to get the product out there and start solving the problems that we think we really have a great solution for solving. But I see some place where supervised models can help us solve some of the problems we're addressing. So, for example, long-term roadmap, and really, I mean, this is long-term because I think this piece of AI and ML isn't good enough yet. But I can see using natural language processing as one of the building blocks for making privacy policies more understandable and more implementable. We need more investment in NLP for so many things. I mean, we use it daily, we're using it for privacy technology in the future, but we're using it today, for search, autocorrect, all kinds of things. Voice typing, like my favorite area of explaining why NLP is not quite up to snuff yet. But it's tough. It's a really hard thing to do because of language. And I'm only thinking of the English language. I don't even really know where to begin on other languages. But that's something that's really immature now, but has so much potential for, again, helping us to really scale in the future.
Interesting. So what would your role at Zen Data Privacy be? I mean, and like what are some of the challenges that you are basically looking, and some of the challenges and some of the problems basically in the space that you're looking to solve? And if you can perhaps comment on what the roadmap for Zen Data Privacy would look like that would be great. I mean, whatever you can reveal in this at this stage.
Right. Yeah, it's a little early, and I can't talk too much. I'd love to come back, in the future and talk more about it. Because we are really early. We're like barely out of stealth mode, really. So not revealing too much, but I can say that the whole Zen Data Privacy team brings so much experience from privacy, security, enterprise, cloud, consumer to the table. And the cool part is that where other privacy technology companies are focusing more on things like automating compliance tasks and saving time and money there, we're building tools to what we say shift left for privacy, which is shifting earlier into the development process. So this is a similar trajectory that I've seen security tools have taken over the last 10 to 15 years. So like in security back, I used to be the product manager for Oracle's database security components. And we used to get beat up with buffer overflows in our code and SQL injection vulnerabilities. So now, that was 15 years ago. So now the industry has developed app scanners and AppSec tools, database firewalls, all kinds of things that, but really I'm thinking of the AppSec tools that aid developers in preventing those types of coding errors in the first place. And then I've kind of always seen privacy as being 10 or more years behind security. So different set of problems, but they are adjacent. So now I think we're starting to see some investment, some venture investment in privacy technology. We're seeing unicorns in 2020. We saw 2 new unicorns in the privacy space. And so there's just a lot going on in privacy technology. So watch this space, I'd say.
And I mean, any comments basically on so a lot of a lot of people are now moving to the cloud. So even these big giants let's say telecoms, the shift that I'm seeing is that telecom basically used to have their data lakes and data centers on prem, and now this whole thing is essentially moving to the cloud, right? So would that bring privacy challenges with it? What would what would your thoughts be on that?
Oh gosh, absolutely. I mean, that's where this whole supply chain comes into play, right? Where now, in privacy, you have data processors, data controllers, and then you've got yet another service provider that has admins that have physical access or logical access to data that may be controlled by them, processed by them, but controlled by someone else. So the privacy policy and the agreement around how PII is going to be used, secured, shared, not shared, accessed, that's an agreement between said company and the consumer. So it makes it really complicated, and it's a challenge that we've been seeing since, as you say, everyone's really been moving to the cloud for so many good reasons, just with new challenges.
Interesting. So I think we're already at the top of the hour. So I'll just basically ask one last question that I have. You've worked in like so many this thing verticals within the cybersecurity industry. What was basically like was there any shared knowledge across all of them? Like were there shared challenges? Like any comments on that?
One thing I could tell you, one word: budget. It's like always hard to get executive management to understand the problem and to think like we do. So I think one way I've been able to, or I've seen the C-suite and the security folks really come together, is where we can provide quantifiable metrics, quantifiable like impacts and results, because that's how the finance people and your C-suite really think. So like in one of my InfoSec and privacy teams, we worked with finance to quantify the impact of a breach if it happened just days before your quarterly results come out. So this is something that the C-suite's thinking of, because they're the ones who are out there on stage and meeting with the financial analysts. So the impact that we found for that company, that it was about a $3.5 billion US impact on the value of its shares. So that's like an effective way to bring our issues to them without like talking about like, getting into the depths of machine learning and classifiers and phishing and banking trojans and those kinds of things that we're all interested in. But it's really the dollars and cents and the share price that means now you're speaking their language.
Yeah, and I think I can relate to that as well. Yeah. No, and this was great. I mean, like it was great to have your insights, Kristy, and this was a really interesting talk. And to our audience, basically, who joined, thanks a lot as well. And have a very nice rest of the day. Thanks a lot, all.
Thank you.
Thanks, Kristy.
Thanks. Awesome.
All right.